Welcome to our 7th modding bootcamp. To lead it, we've got Leon Beilmann, also known as Laxman. He's been a Arma modder for a long time, and now we're fortunate enough to have him here at Bohemia Interactive in the Arma team. So in this workshop, he's going to be going over what a sound in the context of Reforger means, how to use the audio editor, and then how to mod an existing sound, this case in the context of footsteps. With that, I'm going to hand things over, so take it away, Leon.
Hey guys, so thanks for the introduction, Evan. My name is Leon, aka Lexman, if you've been in the Arma scene for a while. And indeed today it's all about audio. Before we start, I want to make clear what exactly the scope of this whole thing is. We will do nothing like super fancy advanced. This is a bootcamp after all, meaning we'll really go over the basics and basically get you from, I have actually no idea how the audio tools in Fusion work, to, I see something and I think I can somehow put where this belongs, basically. But before we started, there's a little announcement, which is that over the past year, I've been working quite extensively in updating both our internal documentation and working on ways together with our very own Lou to basically sync the Biki, or external documentation as we call it, with our internal documentation. And we made great strides in that. I'm super glad that Lou was able to jump in there as well. And as a result, we got this, which might not look like much, but it's actually a large part or a larger part of our internal documentation currently being fully ported to the Biki, and also the possibility of keeping it updated more frequently in the future. So if you're watching right now or later, take a look at the audio section of the Biki, because it is currently being filled and will be even more filled later on. This includes everything from a pretty thorough documentation about all the nodes in the DSP editor, for example. And it even goes over very specific stuff like how are doors set up, how does collision work, multi-phase destruction, and how is occlusion set up, including visual examples, etc. Because this is basically a one-on-one, port of what we use internally. And I'm, as you might be able to hear and tell, very excited to share this because, I've been an Arma 3 modder for a long time and I know what it feels like to not have this sort of knowledge, and being able to finally share it and everything comes together. That's great. So that's that. But we're here to actually get some hands-on stuff in Fusion, so that's what we'll do. All right, to get started, this is the Arma Reforger workbench. And many of you have probably already seen it. Some of you might have been working in the world editor, the particle editor, animation editor, scripts, etc. But let's assume we've never even looked at the audio editor, which is this little thing right here. Click. And I try to put myself in the shoes of someone who is not very familiar with audio in general, and also not very familiar with the Fusion workbench or the, let's say, game modding in general. And I think many people might be a little bit confused at first, because this doesn't look very much like audio, right? We have this little meter here to the right, etc., but there's nothing that screams like waveform or whatever. And that brings me to probably one of the most important things to mention in the very beginning. Something we have to understand is that the audio editor, both in Fusion and many other engines, is not really there to create sounds in a sense. It is there to composite sounds, meaning the actual creation of sounds, of samples, etc., happens outside, just like you would model a 3D model, not in Fusion, but you would import into Fusion. And then you put everything together to the final prefab. And it's very similar to audio in the audio editor. So what is a sound in the context of Fusion? Many people, when they think about sound, have, for example, a WAV file in mind, an MP3 or whatever. It is a single file, you play it back, it does a sound, it makes a sound, and that's it. But if we think about it in the context of a game like Reforger, let's say we have a gunshot. A gunshot is not just one sound, right? If you've played, you will likely have heard that the sound evolves over distance, it uses different sounds, or well, it sounds differently depending on the environment you're in, yada, yada, yada. Meaning just having one WAV file for something will, in most cases, not really do the trick. So what Enfusion uses are so-called ACP files. And those ACP files are basically you could call it the compositing stage. We can create an ACP file by clicking on File, New, Project. And I've already created a mod here. So if you don't know how to create a mod, feel free to look into the very first entry of our modding bootcamps where everything is explained. Let's just create a new file and we call it test sound. And that's it. And now we are greeted with the very, very, very first basic setup of the so-called audio editor. There's also the signal editor, but we will get to this a little bit later. Now, a little explanation of what we're seeing right now. And by the way, I'm using the default layout, so this is literally what you should be able to see if you open up the audio editor for the first time. A lot of the stuff here is not really relevant for getting started. What you might want to keep an eye out for is the log console down here, as well as the listener setup over here. And the listener setup really is our very, very best friend because it is basically a small little 3D world that we can navigate just like the world editor. And whenever we play back a sound in the audio editor here, it will take this listener setup here as a reference. So this will be our sound source in the middle, this red dot. And if we play back a sound, it will behave just like in an actual game. You know, like right now it would be to the right and a little bit further away, for example. Okay, so how do we set up a sound? First and foremost, if we want to use a completely new WAV file anywhere, and by the way, Enfusion only takes WAV files, no MP3s, very important to know. I have a random footstep sample here, for example. If you just drop it in a folder somewhere, you might think, oh, I'm good to go, I can use it, I can even double click on it, and it will play back the footstep sound. It works, right? Wrong. Just like pretty much any other file in the Enfusion environment, files need to be registered. And we do this by just right-clicking it and then going on register and import. And this is very important because if we don't do that, the file will not be able to be referenced in, well, other places within Enfusion. And this can lead to some nasty errors. And it's been an issue that I've been reported quite a few times. I've seen quite a few times, so keep an eye out for that. So to get started, we'll create a very, very simple sound setup. And why not even use just this little test footstep here? Over here, we have all the available nodes. The Enfusion audio editor is a node-based editor, meaning there is no timeline, there is nothing that shows us any progress. Everything is done through nodes. For example, this is a node, this is another node, this is a node. And why not even just another node? So many nodes. And all these nodes are connected in sequence, basically. And the core node, as I would like to call it, for pretty much everything, usually, is the bank. Because the bank node here is the node that actually stores our WAV files. The very tedious process of adding a file would be to scroll down here, go to samples, and then add each sample individually. But let me tell you, you don't want to do that. What we can do, I'm just going to delete the bank and put it back in again. You can just drag files into the bank and edit this way. So if I edit again, it will be edited twice. And if you hold Shift, and this is probably the thing that you really want to keep in mind, if you hold Shift, you will replace all samples, meaning it will get cleared and the files that you have currently selected will be included here. So now we have a bank, and if we play back using the spacebar key, we can hear that indeed the bank plays back the sound. Incredible. But let's think for a moment. If we are within the game world, usually sounds get quieter over distance. There is some filtering going on, meaning like the higher frequencies get lost, etc. So a lot more is usually happening than just a sound being played back. And we can already see, I told you about the listener window. Even if I turn away, if I look into a different direction, nothing happens. It doesn't get quieter. The direction doesn't change. Yada, yada, yada. And this is where the so-called shader node comes into play. The shader node is basically, how should I call it, some sort of mothership for other nodes that handle how the sound behaves over distance. So let's first connect our bank to the shader. And why not call the bank footstep? You can change a bank's name with pretty much any node's name over here in the common attributes. And the next important thing is that most nodes in the Infusion workbench or in the audio editor are somewhat context sensitive when right-clicking. So the shader doesn't look like much in the beginning. We only have like an input for the files, for the audio stream, and an amplitude input. But once you right-click, we see it actually has also a speciality, frequency, DSP, incident angle, etc. Don't worry about all of this for now. It's just important that you will find this with most nodes. So don't hesitate to try it everywhere and just explore what's there, because I think many people miss out because they're not really aware of that. But let's start slowly. So we have the footstep. We have a shader. And let's add a speciality input. And speciality basically defines how localized a sound is, how spatialized it is within the game world. So if I add another dedicated speciality node, it looks like this. I can connect it then to the speciality shader input, and nothing changes. Why? Because our spatiality factor is set to 0, meaning it is never spatialized, it is never put into the game world, basically. So what happens if we change the spatial factor to 1? Whoa. It's played back from the position. Cool. Just for the shits and giggles, we can also put it to like 0.5, which would make it semi-spatialized. So it's a mix of stereo and spatialization. Cool. Moving on, the next input that we have here is the amplitude. There it is. And the amplitude really is nothing else but the volume fall off over distance. So by default, nothing would happen because there's not much set here. We can set a very simple one through R curve. Now we have an inner range, meaning within this range, the audible volume will not change at all. Let's leave it at 1 meter. And we have an outer range. And once this outer range is reached, the sound will not be audible at all. And I hope you can see it at the bottom left here. We can see the distance. So you always know how far away we are from the current sound source. And if we move away from this little orb here now in the listener window, you can hear that indeed it is now spatialized and gets quieter over distance. For testing purposes, let's increase the amplitude, the outer range of the amplitude a bit more. Now it's a bit more audible. Also the slope factor, which is basically how steep this curve is. 40 should make it more audible over a larger distance. Yeah. Then finally for the shader, at least for now, we have the frequency. And the frequency is, well, it is technically a so-called low-pass filter, meaning depending on distance, only lower frequencies will pass through. This is primarily used to mimic the real-life phenomenon where the further you are away from something, higher frequencies tend to attenuate, meaning higher frequencies basically just go away. So we can enable the distance attenuation, leave the air absorption light, which is a lightweight filter type that tries to emulate the real world air absorption as good as possible. And if we move further away, there now will be a filter applied, though it might not be as audible here because the audible distance isn't so large. So if we put this to like 1.5K, you can slightly hear it getting attenuated in the higher frequency spectrum. And voila, we inserted a sound that we just imported and registered, very important. And we connected it to a shader node and applied the spatiality, amplitude, and frequency, meaning we just decided or set how the sound behaves over distance. In the most basic way possible, of course. Which brings us to the next node, which is the sound node, and it is arguably one of the most important ones. Because the sound node is the node that will decide how your sound is actually called. What do I mean by that? We can pretty much copy all of this. And now we have technically two sounds in one ACP, right? So if the game later wants to access our ACP, our sound file here, we need to tell it basically, or we need a way to distinguish these sounds. And in Fusion, sounds are distinguished by the names of the so-called sound nodes here. So if I would call the sound here, for example, sound footstep, and the other one sound test, don't read too much into it. Now, if we later try to call a sound in this ACP, we can reference this one here as sound footstep, and it will play back this sound. And we can reference this one as sound test, and it will play back this sound. It is pretty straightforward, but it might be a bit hard to wrap your head around right now because we haven't yet talked about how all of this interlinks with the actual game. So bear with me for a second, please. And finally, we got the mixer node. When you click on mixer, you will basically just have the option to use the final mix because that is Reforger's mixer basically. And if you've ever looked at the main menu of Reforger in the audio section, you will see that there's those sliders for music, sound effects, etc. And simply put, this is the place where all of this happens. And there is a lot more magic going on in this mixer, but this would be way too much for this little bootcamp here. So for now, all you need to know is that you can right-click this mixer, or output state, as it's also called, and then look for something that sounds like it would relate or would fit to whatever sound you're doing. In this case, for example, why not just put it to random SFX, a random SFX channel, and then we can link our sounds to here. Ta-da! And it would now be properly processed in the final mixing of the game. So, in summary, we added a sample, we declared how it behaves over distance using the shader node, and then finally we named it with a sound node and put it into the mixer so it's properly processed by the mixing of the game. And this is pretty much the most basic sound setup that you can have. We could technically, of course, completely omit the shader node, but this would result in that the sound here is always, again, playing as if you would play it back in some sort of media player. There is no attenuation, it's not spatialized in the game world, etc., etc. This could be used for UI sounds, for example, where you usually don't want it to be placed in the game world, but just be, played back in your head, basically. Okay. Let's get to the, let's call it, actual modding part, which is a little bit more complex. Bear with me, but I think it will make sense in the end. I've already prepared our world editor here. So we've just created an ACP file, right? And if you've been modding Arma 3, you might remember that, for example, there are some CFG sounds that you could declare and then basically use wherever. You could just use some scripted command and the sound would be there. That's not quite the case for Reforger because we use a component-based system here. And basically, you have to understand in the way that you can only play a sound if the object actually has the sound available somewhere. If we, for example, click on this M16 here, we see that the M16 has a so-called weapon sound component. Aha. If we click on the weapon sound component, there is an array called file names. And this array includes all the ACPs that the M16 in this case uses. Meaning once the M16 is spawned into the game, those will be loaded. Those will be referenced or referenceable, if that's even a word, from within the M16. If we look at the vehicle here, we see that there is a vehicle sound component. Aha, another sound component. So what you always want to look out for is a sound component in some sort or of some sort. And again, those are all the ACPs that are available. Now you might ask, why is there a weapon sound component and why is there a vehicle sound component? How do they differentiate? And the answer really is a vehicle sound component does different jobs than a weapon sound component. And if, let's say, we had some sort of super sound component and that does all the jobs required for every type of entity we have in the game, it would just, be wasted resources, wasted performance. So those different sound components all serve a specific purpose. You will later see that there is also, for example, a character sound component, etc. So important to understand is we need a sound component, usually, not in all cases, but for now, just safe. We need a sound component of some sort on an entity. And then we need to define the ACP that includes the sounds that we want to use. Otherwise, we will not be able to reference it in any way. And those sounds are then either called hard-coded by the game, basically, or you can also call them via script, but that's not for now. Now we get to the actual modding part. Now that we know where to look for when trying to replace sounds, we will actually replace the sounds. And Evan already mentioned it in the beginning that we will try to replace some footsteps. So let's look at characters. I think it's core. Hold on. It's just character base, I think. Yep. So if you look at the character base, and I can't edit it, of course. Okay, cool. Can put it in here. If we look at the character base, a regular Reforger character has quite a few files here, quite a few ACPs, and they all handle different things. Now, what we are interested in is the character footsteps ACP. We can open it up by simply clicking here, open file, and ta-da. This is what the character footsteps ACP looks like. It is a lot. And we want to simplify this. This is the goal of our little mod. We want to make a very, very simple footstep setup. Like most things in Reforger, we can override this into our mod. So we click on this little search icon, which will browse to this particular ACP. We just right-click and then choose override in MBC mod, which is the current mod I'm running, the modding bootcamp mod. And this will automatically create an exact copy, one-to-one, of the original footsteps ACP in the MBC mod folder in my case. And you will see that there's this little puzzle piece here. This means that this is a modded ACP and it will be used instead of the original footsteps. We open it up and indeed it looks exactly the same, but we already discussed that we want to simplify this. So everything will be scrapped. Everything will be scrapped. And we start from absolutely zero. And for now, we just want to use our little test footstep sample again. Actually, why not? Whatever happened here. Why not just recreate everything real quick? So again, we go through it one more time. We drag and drop the sample in here to create a bank. We can call it footstep. Then play it back with spacebar. Then we create a shader. Right-click in order to also enable the spatiality and frequency inputs. And then we want the spatiality, frequency, and amplitude nodes. Our footsteps will be very loud, so they have an audible range of 200 meters. Why not? Slope factor of 15. We enable the distance attenuation by just doing this check mark here, and everything will be fine, connecting it with the frequency. And we want them to be fully spatialized, so always fully locatable in the world space. Connecting our footsteps here to the shader, the footstep bank, the wave files, the wave container basically to the shader. And then we create a sound node in order for the game to be able to actually call this. Now, the hard-coded, well, not technically hard-coded, but the sound event name for footsteps in Reforger is sound car movement foot. Now you might wonder where this comes from. I'll show you very quickly by opening up the animation editor here. You see those animations all have those events. And if we look here, sound car movement foot. So all those individual animations, they all reference this sound event name. And we could technically use any name we want, but it's just that we, internally agreed that sound car movement foot will be the name for footsteps. It's in all those animations, which is why we also have to use it here in our sound node. And finally, we want to put it into our mixer, into our final mix. And character. Car stands for character. And here we go. Now there's literally nothing happening. It's always the same sound. But theoretically, yes, beautiful. We have successfully improved the footstep sounds. But now you might think those footsteps are awfully loud, and I would agree. So let's talk a bit about best practices, quote unquote. There are many parts, many points where we can technically make the sound louder or quieter. For one, we can make the whole sound louder or quieter. So imagine we would have like lots of shaders, etc. It would all be connected here to the sound node. We could make the whole sound quieter by just making it quieter here on the volume slider. But this would make the whole sound quieter. And there are situations where you want to do that. There are situations where you might not want to do that. Generally, I would consider it a good practice to use the volume slider here on the banks to fine tune it. So in this case, it was very, very loud. Let's say we want maybe minus 10 decibels for now here in the volume. And if we go back into the game now, it is indeed quite a bit quieter. Cool. So let's try to make it a little bit more varied without changing the samples for now. What we can do is change the volume variance a bit, and putting it to 2 means that the volume can either go up or go down 2 decibels. And the same is true for the pitch variance. The pitch will now either go up or down 3 semitones. Where is it? There we go. So if I now walk again, you can maybe hear, you should be able to hear that there is some pitch randomization. Actually, let's make it a little bit more obvious. Why not? Yeah. And this is a very, very easy, very, very sleek way to get some sort of variation into sounds, even though you might only have one or like a handful of samples. Some volume, some pitch randomization can really work wonders in some cases and spare you from having to do a lot more variations. Okay, so now we have a very basic footstep sound, but it just doesn't cut. It just doesn't cut it, right? So luckily, and that is also something I want to highlight, all sounds available or present in the regular Reforger are also available for modding. So you might see all those scary blocks here, but don't worry, they are absolutely usable. So we just go to walk and let's get some default footsteps in. So I'm going to replace, again, shift drag, replace the samples in the bank that we currently have. And it will now be the array of the default Reforger footstep layer. But this layer is basically just meant to be a base, which is then combined with the actual surface. So what we can do is Control V, copy the bank, and then, for example, go to grass. And now we put all the grass footsteps in here, and we call it footstep grass. We can now also connect it to the shader. And now we have the base footsteps and the grass footsteps. With the heavy pitch variation, let us bring that down again, sorry. And both play together because both the regular footsteps, the base layer, and the grass footsteps are connected to the shader. And if we go into our game again, indeed, it plays both. Neat. Now, let's spice things up a little bit and talk about signals. Now, signals are a technically straightforward topic that might be a little bit weird to explain in a sense. First and foremost, let's talk about the game signals. Game signals are basically values that are present on characters or set on characters and entities and many other things that represent their state in some way. For example, if I walk as a character, I'm just gonna turn down the volume, this time on the whole sound, because I'm lazy right now. Yeah. So if I move with the character, we have a speed signal. And now you might ask, well, Leon, that's very nice, but how the hell should we know that? How do we know that this character has a speed signal? Now let me introduce you to the beautiful world of the debug menu console, or debug menu, which you can open up by holding Control, Windows, and Alt. And from there you can use the arrow keys to, for example, go to sounds. And let me look. Chimera sounds in this case now with 1.3 experimental. And there we have the signals debug. The signals debug allows you to, well, debug and watch the signals of things around you by clicking here. So you can go through all the entities around you. So in this case, we have the US Rifleman, which is us, and we are currently debugging his character sound component, which we know has our now modded character footsteps ACP on it, right? And we can now watch and debug all those signals in real time. And what we're looking for is speed. So I can search here and then use speed. And you can now see that once I start moving, the speed signal actually increases and decreases depending on my speed. Now this tells me, okay, I have the signal available in the audio editor. It is a signal available on this character sound component. Or to be more precise, it is actually stored and managed by this signals manager component. But let's not get too deep into that. But how do we use this value now? Because, there's nothing here that screams, hey, let me interface with the game world, really. In order to do so, we need to first create a signal file. And yes, we, on the one hand, have the signals that are the values in the game, and then we have signals that are audio editor specific files. This is where it gets a bit confusing, bear with me. So we click on File, New, Create Signal, and let's just call it, let's do it properly in here, quote unquote. We call it footstep test signal. And you might see that a new window has opened, and it looks very, 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 very similar to the audio editor. And I guess it technically still is, but don't be fooled. We are actually now within the signal editor, not the audio editor. This is the audio editor. Look at the available nodes here. We are currently working on an ACP file. This is the signal editor. We are working on a .sig file. Okay, so let's scratch everything for now. And first we want to start off with an input. And the input will be speed. Cool. And you might have guessed why. Speed, simply because speed is the exact name of the signal that we want to use. So if we use a signal in an ACP and it has the exact same name as an available signal on the entity, then it will be used. And it really is as easy as that. So by placing the name speed in here, or the input and naming it speed, this is now referencing the speed signal if it is available on the component, on the sound component. So getting out of here, back to the signal editor. And what I would like to achieve is, I would like to have the footsteps quieter when running or walking slow and louder when walking fast. So let's create an output first. And we just call it footstep _ V for volume. Now in between happens the best friend of most people on this planet, maths. Now I know what you're thinking, that might not sound too enticing, but in the end everything we're working with here are just values. So if I, for example, place a value node here, let's call it 0.4, that's the name, and then we can also change the value of the value node to 0.4. Now we know that this is a value node and it has the value of 0.4. And what we want to do is think about it in percent. We want to have 40% volume when the character is walking very, very slowly, and we want to have 100% volume when the character is walking very, very quickly or as fast as possible. What we can use for this, there are many, many methods, and you see there's a lot of nodes, and I will definitely not be able to explain all of them. But one of the cooler nodes definitely is the interpolate node. And it might look a little bit scary at first, but it's really not so bad. Now, if we connect the speed input that we created, remember the reference to the signal on our character, and put it to input here, this interpolation node will now receive our character speed as an input. And now we have x min and x max and y min and y max. And x min is basically, okay, so x min correlates to y min and x max correlates to y max. If I put a value, pardon me, if I put 0.4 in here, oh, I just realized, sorry. Okay, I got a bit tangled up here. We technically don't really need this. Ignore the value, we just need this node. So we get speed as an input. Let's start over. We get speed as an input. And what we're saying now is, if our speed, and the character runs at around 5.5 meters per second maximum. So let's say if our speed is 0.5 minimum, then we want y, which is the output value, to be 0.4. But if the character sprints, which correlates to around 5.5 meters per second, so speed will be around 5.5, then we want the value to be 1, meaning the original value. And we can debug this using the so-called signal simulation. So down here, we have signal simulation here. And if you click on it, we can see all the current signals, or all the inputs, to be precise, in the current signal. And if we now press F5, we can switch to the debug mode. So if I now change the speed, we can right click here to edit min-max, because by default it is 0 to 1, but our interpolation node here goes to 5.5. So let's switch this real quick back to the value. So now we can see as the character speed increases, the returned value also increases. And 1 in this case means 100% basically, meaning 0.7 would be 70% of whatever arbitrary volume this is, but we're going to use value this is, but we're going to use it for a volume. So now we can connect it to the footstep V output, save our footstep test signal, and go back into our character's footstep ACP. And going back into the resource browser, we can now go to sounds, character, and here is our footstep test signal, 0.6. Dragging it onto here, and ta-da! This is the signal we just created, referenced as a note, or shown as a note, within the actual footstep ACP now. So you can see we have the speed input and the footstep underscore volume, or V output. And now we have it here as well, speed and footstep volume. Now we want to right click on the sound node, and we have the volume input here. And the volume input works in a way that 1 basically means 100% and 0.5 means, 50% if you want to put it this way. So all we need to do is we need to connect the footstep volume to our volume input now. And if we did everything correctly, can close this. We should now be able to have an audible difference in volume the faster we go. Yeah. Nice. And just to mention it again, of course, there's a lot more you can do in those with the signal editor, but we will really just skim the basics for now. And technically, this would already be a completely modded footstep, but let's take it one little step further, because currently we have just one footstep for every surface, but we have this beautiful vehicle here. And wouldn't it be nice if we would have some metal footsteps on here instead? So how do we do that? If you now thought maybe we could use signals again, then you would be completely right. Let me show you another nice way of showcasing signals, debugging signals. If we press the Control Windows Alt shortcut for the debug menu and then press C, we can go into a free-floating camera. Ta-da! Watch our character. Some of you might have used it already. And now if we go to Signals Debug by Entity, this little window opens. And now I can center the camera. There's this little white dot here. I can center it on the character, click on Lock to Entity, and now it is locked to the entity. So this way you can point out specific entities very quickly and track their signals. Now what we are interested in is the so-called surface signal. And right now you might see that it is 0 because we are on the beautiful MP test map, which has no surface signal assigned, but the roof of our vehicle here should have. Yep. So every surface, or most surfaces, ideally should have a number that corresponds to the respective material. And in this case, this metal here is 6,110. So now we know that if we are somehow able to switch the sound that is played based on this number, we should be able to switch, well, the footstep sounds depending on surface. So we have 6,110. Let's look into it. First and foremost, let's start with the sounds themselves. We want footsteps metal, so I just copy paste the footsteps grass, and we again can access our already available quote-unquote sound library that comes with Reforger, metal, and we're just gonna put those here. Yep, that's metal. All right. Now let me show you the beauty of the selector node. It's this one. And the selector will basically switch the input based on a value or a signal value. So first and foremost, we will say we want to have our footstep default using the ports here, adding a second port. Let's call it footstep metal. Cool. So let's do some, let's say, design thinking here. We said that this here is the base layer for pretty much all footsteps that goes together with other things, with other footsteps, right? With the specific surfaces. So this one technically doesn't need to be exchanged. This one is supposed to remain there all the time. But those ones, the grass and the metal ones, are supposed to be exchanged. Let's make this a little bit louder. Meaning this one can go straight into the shader, the footstep base. But those two we want to exchange based on the material. So we have grass as default, we have metal as, well, metal. And we can connect it to the shader again. But right now nothing would happen because we didn't tell the selector what values to choose, and we didn't even assign proper values to correspond with that. Luckily, there is a very simple surface signal already in Reforger. It is literally just called surface.sig. You can search here. And this will do literally nothing but outputting the surface that the entity is currently standing on or is currently using, that is currently saved in the signals manager. So we can just connect the surface to the selector. And now the selector will use the value that we've just discussed, the surface value when the character walks. We know that metal starts, or our metal in this case, is 6,110. So we can say our default footstep, we set it to default, so it's used if the value doesn't match anything. We go from minimum 0 to 6,110. And it is important to understand in the selector that the max value is not included. So it is everything up to 6,110, but not 6,110. And for a footstep metal, we just say 6,110 as a minimum, and I don't know, 6,120 as a maximum, whatever. Okay, whatever that was, I think it's because I'm running here. I have no idea why it's doing this. Hold on. You know what? Let's make it even simpler. We can also just get the surface signal in our own signal that we created before. Just call it surface here. We just call it surface there and link it. Because remember, as soon as we name the input of the signal the same as the signal that is available on the character, it will be referenced. So now we can just connect our surface here to our selector. Let's put it up here for better visibility. And what we just did is the following. If the surface signal is between 0 and 6,110, but not including 6,110, this input here will be used. But if it is between 6,110 and 6,120, not including 6,120, this one will be used. And remember that we had this signal simulation in the signal. The cool thing is we can also use the signal simulation in the actual ACP. So we can test if it's working by simply switching the surface signal. We again need to edit the min and max values. We know that 6,110 is the maximum that we want to use right now. So right now, the surface value represents 0, and it plays the grass. If you go up, it still plays the grass. But once we go to 6,110, it switches to metal. I still want this to be a little bit louder. And going back to the world editor, getting rid of this beautiful debug. Grass footsteps, cool. Jumping onto the vehicle. Metal footsteps. All right. And I would say that concludes. Yeah, that pretty much concludes it. There is one little thing that I don't want to miss with this bootcamp, which might be confusing for newbies. So it is what it is. But for those of you who are a bit more confident in scripting already, you might ask yourself, how do I actually call a sound event myself? And that is very, very simple. A good example here is in the SCR mortar muzzle component. First and foremost, you want to get the sound component, right? Because this is what will be used to play it back. So you need to get the sound component by casting to it, which is this line here. And then using the sound component, the method is really just sound event, and then the string of your sound that you created in the audio editor. And that's it. That concludes our little bootcamp for audio. I hope that you've learned a thing or two. So thank you all for coming and have a good one. Bye-bye.